Hey everyone, today I'll be going over Leetcode 763, partition labels. You're given a string S. We want to partition the string into as many parts as possible so that each letter appears in at most one part. So return a list of integers, basically representing the size of each part. So confusing description, this is actually one of my favorite problems, like top 5. So I'm going to explain this the easiest way possible because this could be confusing. Basically, we want to partition this in a way such that a character appears in most part. So if we actually look at this string, let's just take A for an example. So if we look at A, the last point in which we see A is here. So let's see if we can partition it this way. So we have B. Does B appear elsewhere? No, it doesn't. Does C appear elsewhere? No, it doesn't. So we can actually partition it this way. And this is actually 9 length, so that's the 9 in this output. If we look at D, E, and F, and we also have E, we have to look at the last point we see D. So this is the last part we see D. Can we partition it this way? No, we can't, because there's this E here. So we kind of like move that forward. Can we partition it this way? F, is it seen in here? No, it's not. Is G, is D? No, they are not. So it can actually be partitioned this way. And then this is 7, and this is 8 as well. So this is actually exactly how we partition it, but we don't have to return these partitions. It's just the length. So this would be like, 9, this would be 7, and this would be 8. And that's like literally the answer here. So when I was going through this like intuitively, you can kind of like see how you solve this like on paper. And you just kind of like look for the last point we see a character. We make sure that like none of the characters are like beyond that last point, and then we like chunk it out that way. But there's a better way to do this, and we're going to use exactly that logic. So another fun trick we can do, if we look here, S only consists of lowercase English letters, which means we can just use a character array or like an integer array from 0 to 26, so that represents all the characters, and we're going to do exactly that. So we're going to call this last scene, and this is going to be a new int of size 26, so they're going to be all 0 for now. And all we're going to do is keep track of the last point we saw each character in the string. So basically, now what we're going to do is we're going to simply go for int I and go up to through the string, and all we're going to do is last scene. We're going to go s.char I minus a is equal to I. So what this does here is basically we index it. So a will map to 0, and so it's a way that we can like represent this as an array. So basically we're just keeping track of the last index we saw each character in this string. So now that we have that, basically what we want to do is we want to go back through, and we're going to also need this list, right, as the result. So let's put that here at the top. And we know after everything, we are going to return it at the end. We're going to do some stuff before then. So now we want to go back through the string, and we want to do a few things here. So basically, we want to keep track of the max length that this, or the ending length that this partition has to be. So I'm going to call this end for now. Now, the reason why we need to do this is it's exactly the logic I was talking about earlier. It's because we can't partition it if the character in this partition exists in another partition, because the character can only exist in one partition. So we have to keep updating this end as the last scene here. So basically what we're going to do is we're going to go back through the string one more time, and we're going to update the last scene, or sorry, the end. So the end is the last scene of this character, or the max. It's like the max reach. So we're going to update this, and we're going to go last scene of s.char at I minus a, and we're going to update this end here. So now, what's going on here? So basically, how do we know when we can partition it? Well, we know when we can partition it when the I is equal to end. The reason being is because if I is ever equal to end, that would mean that all the characters' last points in this string have been accounted for, and they're not going to exist in any other partition. So we can actually just take this, and what we actually do, and what we really want is, we really want to do a start here, because we also need to know the length of it. So the start is just 0 at the beginning. So what we really want to do is we want to add the length of this partition. So that's going to be n minus start plus 1. We have to do plus 1 because you know the indexing. So it's kind of like if we're at index 4, 4 minus 0 plus 1 would be 5, and 0 to 4 substring would be length 5. So that's why we do this. So we do that. And basically, we only do this if we reached the end, right? So if I equals the end, so like I was talking about. So we do that here. We also have to do one other thing. We have to also update the new start. So the new start is going to be basically I plus 1. The reason being is because we just partitioned. So we have to create a new partition. So we have to set a new start of the next partition. So we do it like that. And this looks pretty good here. And basically, let's see, let's just double check everything. And yeah, this actually seems fine. Let's go ahead and run this. And yeah, looks like we get it here. Let's do one edge case here just to make sure. This should be just 10 because the entire thing's a partition. And it looks like that's right. So let's go ahead and submit this. And yeah, pretty good. I like the time, I like the space. So let's talk about time and space complexity. So there's a lot of stuff going on here, but what's really happening? Right away, so with space, when we talk about this, we don't really count the output. So the res isn't gonna matter. So we wanna talk about everything else. So the space actually technically is O1. And here's why. Because last seen is bound to some fixed value because we're only using lowercase characters, so it's really just O of 26, which just condenses to O of 1. It's always going to be fixed. Now for time, we have a few loops here. We go through it once, and we fill up some stuff. We go through it once more, and we fill up some things here. We're really just going through it here. This is just an if statement, so really it's 2 loops. So 2 loops, 2n, which is just going to condense to O of n. So O of 1 space, O of n time. And yeah, I hope this was helpful. Thanks for watching.